This is the second video for Module 3 in 1121. We're going to go over messaging in this particular video. Hopefully you can see the desktop. I'm not sure this is working. I'm hoping it's working. Yeah, okay, there's my item in the side. Okay, good. Hopefully you can see the desktop. You can see that there is a slide open for message size. So we had mentioned a few seconds ago, or in the last video, to kind of pick up where we had left off. We're going to be able to send about 1,500 bytes at any given point from one device to another device, and if we can't fit everything that we need into one datagram or protocol data unit, we're going to create multiples, and we're going to use values that are going to keep track of those some of the time. So we have two different types of data that we can send. We can send what's called reliable data, and then we can send something called unreliable data. Now here's the thing. Both of them work, and they're both used. Even though something's called unreliable, we still utilize it, and we utilize it for things like streaming audio and streaming video mainly, because we're going to go ahead and just say, you know what, I need to move this information as fast as possible to the destination, and if I lose a little bit of the quality, or if some of the stuff shows up out of order and it just kind of doesn't click out correctly, it just maybe jitters and causes something to freeze. On the overall, we're going to be better off than if we were to try and build something that would guarantee the delivery of the entire program, right? So streaming audio, a lot of times live video, live audio on the internet, Skype meetings, collaborate meetings, a lot of that audio is going to be in a UDP format. It's going to be unreliable. But when we create something like a video like this that you can download and watch, it shouldn't have any beeps and blurps and blobs, and it should come out with the quality good because it's going to be reliable. You're going to download that file onto your computer, and each datagram that comes in is going to say, okay, I belong in this position in the entire string of datagrams, and they're going to glue them all back together in the same order, and boom, you're going to be able to play it, and it's going to work out the way it's supposed to. So keep that in mind. Most of the stuff that we send is going to be larger than just one datagram, and there has to be, or sometimes there is, a negotiation to go across those. So that's what they're getting to in this slide. The next slide talks about the idea that, okay, well, if we're going to send multiple datagrams from one device to another, what are the rules that we're going to live by in order to get that other device to accept this information? And part of that is we're going to have a rate that we can send information, because it's possible between two devices, if one device is sending information at one rate and the receiving device can only receive the information at half that rate, that means that half of the stuff that comes into the receiving device isn't going to get processed. It's just going to fall on the wayside. It's not going to be used. So that's a bad thing. So like I said, with streaming audio and video, we just kind of push it out and hope that the receiving device can handle it. But in a lot of other cases, what we'll do is we'll manage something with a flow control. And flow control is a pretty simple concept of, I have, X number of datagrams that I want to send, and my receiving device is going to start receiving those. So what we're going to do is we're going to start low, and then we're going to build up and see how many we can send before everything crashes to the ground. So starting with flow control, I can say, what's my maximum transmission unit that I want to send from my device to my receiving device? And those two devices will negotiate on that. And they'll say, hey, I like to send about 1,500 bytes. Well, I like to receive about 1,500 bytes. Okay, so let's make it 1,480 bytes. That's the most stuff you can send all at once to me. I'll be able to handle that. Great. Now, how many packets can you handle, or how many datagrams can you handle before you ask for more datagrams? And let's just start at 1. Okay, and this is a value known as the windowing size of the datagram. So we'll start at 1. So I'll send 1 datagram to you, and you'll receive it, and then you'll send me back an acknowledgement that says you received the 1, and that worked out so well. Why don't you send me 2 more, and then I'll send you another acknowledgement? Okay, so then I'll send 2, datagram 1, datagram 2, and I'll wait. And the receiving device will get those, and it'll go, wow, I got those in good order. This is working out really good. And an acknowledgement comes back and says, you know what? Send me 4 datagrams before you have to wait for another acknowledgement. So I'll send out 1, 2, 3, 4 datagrams, and I'll wait, right? So obviously, the more datagrams you can send without waiting, the faster this whole thing is going to go. But there's a process to it, so it builds up. And then if there's ever a time when maybe we get to 8 or 16 or 32 or who knows how many, and there's a failure, the receiving device says, whoa, 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 slow down, you're sending too many at a time, guess what? We start over at 1 again. We go, oh, okay, that was too many, we lost something there. Let's get a retransmission of what was lost, and then let's start over 1 at a time, let's do this again. And that's the process that's used between devices in TCP/IP. So there is a flow control and there's a windowing communication for that, okay? So it's a little bit about how messaging works. Now, the next thing is we can deliver stuff to one device. We can have stuff delivered to multiple devices that we select, or we can have stuff delivered to every single device. Now, let's start with the data that we want to send. Pretty much in the models that we've been talking about, it's a one-to-one communication, right? I've got information I want to send to someone else's end host device. That's going to be a one-to-one or a unicast transmission. I want to send it to you. You're going to receive it. You're going to send me back something, and it's just a conversation between the two of us. Great. That's 90-something% of all the information. Now, I'm going to skip over multicast for a second and just jump over to broadcast over here. So when we look at broadcast over here, all the little lights on the computers as the receivers are lit up this time. So when our source sends something in, it's going to actually go to all of these devices at the exact same time. And that is a method used by what's called a wildcard MAC address that tells the switching device, don't just send this to one device, send it to all the devices. And we'll get into how that works in another presentation. But for now, just know there's something called a broadcast. And in most cases, the broadcast is used so that you can qualify and identify a receiving device. Sometimes you don't know all of the addressable information for a receiving device. So for instance, I'm a sender and I want to send information to host A. And all I know is host A. Okay, well, before I'm going to send that information to host A, I need to know host A's IP address, and I need to know host A's MAC address. So the process that we use to resolve a host name to an IP address is called DNS, and more on that in another presentation again. But I'm going to go to a DNS server, and I'm going to say, hey, DNS server, can you resolve the host name A or host A to an IP address? And the DNS server is going to go, sure, I can. And it's going to send you back an IP address. And you go, okay, now I know the destination IP address that I want to go to. And then with that, you're going to say, all right, well, I need a MAC address to send this across the switch, because the switch isn't going to read an IP address. A switch is only going to read a MAC address. And if you don't know the MAC address where you want to go, then you're in trouble. So another helper protocol that you can use in addition to DNS is there's another one called ARP, or Address Resolution Protocol. And what ARP does is ARP will send out a broadcast message to all the devices on your LAN, and it'll say, hey, devices, if you happen to be this particular IP address, please respond back to this request so that the sender can get your MAC address and send you information. Now, if there's 10 computers that receive this, only one of them is going to have that IP address, because the IP addresses have to be unique on a LAN. So what will happen is 9 of them will not respond, but one of them will. It's not super efficient, but it is an effective method of finding basic information off of a network. So broadcast messages are most of the time used as helper protocols to help a device that eventually wants to send a unicast message to another device but doesn't have all the information that it needs in order to make that happen. Okay? Now the last piece that we're going to go through in this particular video is multicast traffic. And multicast is a kind of a selective broadcast. So let me give you an example. If you were watching a streaming video online, that streaming video online is not available to everyone on the internet. What actually happened is this, is you clicked on a link, and the link that you clicked on told the switch and the router and all of the processes in the path to the multicast server, to that video server, hey, I want to watch this. Great. And the routers and switches will work in concert with each other to figure out where the last device is at to split off and send you that information. So if you have to cross 10 routers and 5 switches, each one of those is going to pass that information on to you. Now, let's suppose your neighbor also decides to start watching the exact same streaming video. Now, that's not going to require a second datagram for all of the streaming video across those 10 routers and 5 switches. It's going to get split out at the very last switch. So if you and your neighbor are connected to the same switch, and you're both participating in the same multicast, then you would both be able to receive the same transmission, and it would be a single transmission all the way to the final switch that you're connected to, where it would then duplicate and then send to both devices. So in a multicast, it's a one-to-many situation, but it's a one-to-one situation until it absolutely needs to duplicate to make it one-to-many, and then it makes it one-to-many on that particular device. The idea behind that is it's going to keep the load of transfers way, way, way down so that you don't have to send, if you have 100,000 subscribers that are looking at something, that would be 100,000 streams, not necessarily with multicast. It could be a lot less than that because those streams are all going to be traveling the same path, and then they'll just break out and duplicate at the very last device. That's a little bit about what multicast does. So those are the things I wanted to talk about in this particular slideshow, and then we'll do another one in just a second.